They can take our lives, but they can never take our degrees of freedom. I'd like to talk about confidence intervals for one population mean. The math behind solving these problems relies on the central limit theorem, and there's two versions of that for the mean. Remember this guy? He figured out a better way to sample for the mean using this thing, the student's t distribution. The issue is that sigma represents the standard deviation of the population, and that is supposed to be unknown. But William Seeley Gossett figured out that we can use the t distribution, and that requires the standard deviation from the sample, and that's known. But there's a bunch of different t distributions, and they depend on this concept, the degrees of freedom, which is always one less than the sample size. So the takeaway here is that in statistics class, basically, if you're solving a problem about means, you're going to be using the t distribution. Let's try to answer a really important question that I know is on everyone's mind these days, and that is, how much you're going to have to pay to feed your tiger. Allabouttigers.com. Cost of feeding big cats. Now I'm going to have like the weirdest targeted advertising. What is my Facebook going to look like next week? Let's unpack the pieces of this problem. So the first one is this $6,387.50 is an average, and this comes from a sample. So that means that this number is the sample average. We use X bar to represent the sample average. 30 is the number of zookeepers that we sampled. Oh, actually 30 is the number of zoos that we sampled. So that makes this N. And then they give us the standard deviation of the sample. That makes this S sub X. I'm going to use the built-in functionality of the TI-83 calculator. So I push the stats button and I go over to tests, and I'm going to go down, and then I'm going to choose option 8, T interval. There's two inputs. This time they did not give me the raw data. They just told me the summary. This is an average. So they're actually telling me what the statistic is. So the calculator program constructed a confidence interval, and they ended up with about $6,200 and $6,500. What it's doing is the mean in the sample. So in our problem, this was the 6,387.50. And then basically they're adding and subtracting on two standard errors. This number you get by doing S sub X divided by the square root of N. And then this, sometimes we've been calling this the level 2 number. In the Z distribution, this was 1.96 to put perfectly 95% of the area in the middle. So depending on which t distribution you're using, how many degrees of freedom there are in your example, there's going to be a different number that goes right here. And so because that number depends on the t distribution, you'll see it called T star. It's just whatever the level 2 number is for that specific t distribution. The old school way of teaching statistics was to have students memorize this X bar plus or minus T star times S sub X divided by the square root of N, and then use one of these things called the t distribution table. And you can see it's really just a busy table that tells you, depending on what your degrees of freedom are, so we want a 5% area in the tail. See, it doesn't go down big enough. This only goes to a sample size or degrees of freedom. So this is a sample size of 18. The point I'm trying to make here is that it's just much better if we just use the computer so we can focus on the interpretation of these things. Like the other kinds of statistical inference that we've done, the conclusion is a technical statement, and so it really needs to have a very specific form. it's always going to pretty much look like this. And let's go through and fill in the pieces. So for our problem, we were 95% confident. That came from the question. In this blank, you always put the context of the problem. So in this problem, it's about the average amount of money that a zoo would spend on feeding a tiger. I put the population mean tiger food monthly spending. The English is a little bit awkward here, but it's important that you always reference the parameter, which in this problem is the population mean, and that you always talk about the context. Between $6,229.30 and $6,545.70. Well, there is some fluke chance that the zoos that I happen to sample, maybe they were all just like luxury zoos in LA where they feed their tigers filet mignon. And because of that, it's thrown these statistics off. So it isn't plausible, but it is possible that the true population mean is outside these numbers. I'm going to repeat this problem. I'm just going to change some of the variables so that we can see how useful this information is. The width of the original interval, I got $316.40 difference between these two. So I feel like our prediction was pretty good. All right, we did much better in example C. That makes sense to me. We have a lot more information. We have a much bigger sample size, and the width of the interval came in much smaller than when we had a sample size of 30. Whoa, this time I got a width of $746. So this is starting to get concerning. If I'm $700 over budget on my tiger food, then my zoo may shut down. I may end up in jail or something. Jeez. So you really got to be careful with the standard deviation of the sample. That's what S sub x represents, because if that number gets too big, then the confidence interval gets very wide, and you're not really making very precise predictions. I'm starting to feel like I've been ripped off by the chip company, and I want to figure out what the mean weight of these bags of chips that I've been buying is. Oh, I forgot to assume normality. I had to include this assumption that the weight of chips was normal because I only sampled 5 bags, and that sample size is not big enough to use the central limit theorem for means. The thing that's different about this problem is that now the data is given to you as a list of numbers instead of as the summary statistics. So that's not a big deal. I'm just going to put this data in the list. After you have the data in the list, you can either calculate the summary statistics manually, and it will give you the sample standard deviation and the sample mean. If you do that, it will automatically populate the numbers in the t interval. Or if you want to skip that step, you can just put the data in the calculator and then have your t interval input set on data. And then since I put the data in L1, I want to make sure that this list is on L1, the frequency is always on 1, and my confidence level is 95%. I am 95% confident the population mean weight of bags of chips is between 8.4 and 13.0 ounces. Ooh, I like this. Put the conclusion in a little box. That makes me feel good. This is not a very good estimate. You know, I was really hoping to be able to rule out 12 ounces. Is 12 ounces plausible? Look, all these numbers, 10, 9, 11, and 8, all of those numbers were less than 12. So our data really suggests that 12 is not a plausible number. However, since the sample size was very small, this only comes from 5 bags of chips, I ended up with a really wide range. So what I need to do is go to Costco and buy a bunch of bags. And that's how we construct and interpret confidence intervals for one population mean. Please reach out to me if you have any questions.